Be without you. A periodic function is a function that represents its value in regular interval or period. The most important examples are the trigonometric functions, which repeat over intervals or lengths 2p radians, DAN.
An object is undergoing simple harmonic motion if the acceleration of the object is directly proportional to its displacement from its equilibrium position. The acceleration is always directed towards the equilibrium position.
There are two equations for an object to be in simpler harmonic motion. We have the equation for sine function y equals a sine omega t, where the motion starts on 0. The equation for the cosine function y equals a cosine omega t, where the motion starts at the amplitude. In both equations, a is the amplitude of the cycle, and 2p over omega is the period of the function.
The frequency of an oscillation is measured in hertz, h to z. Is the number of oscillations per second. The time of oscillation is called the period of the measure in seconds. And the amplitude is the maximum displacement of the object in the mostly measured in feet, meters, centimeters, of inches. It's depend of the problem.
Hi, we're team number 5 and we're going to present our math problem, that is spring mass system. A mass attached to a spring is moving up and down in a simple harmonic motion. The graph gives its displacement d of t from equilibrium at time t. Now, we have to express the function d in the form d of t.
We have to find an equation of the form d of t that equals a sine omega t. And first, we have to identify the amplitude of the period of the function. We can see in the graph that we're going to do right now that 5 is the maximum displacement. We can observe that each period is p equals 2 over 5, and now we have to get omega to find the equation needed. And we know that p equals 2 pi over omega, so we have to isolate w. But right now, we're going to graph this function. We now know that this function that has a 5 amplitude is going to go 5 up and 5 down. And now we separate this on 4, and we're going to start graphing because it's a sine, so we're going to start on 0 and start graphing. 5 up and 5 down. As you can see right now, we're going 5 down, and then we have to go all the way up 5 again, and then we have to go down. After we're done graphing this, we need to start isolating W. So we're going to do it right now. Now that we've isolated W, that is omega, we're going to write down the answer of our whole graph. That is the length of the graph that we're asked for. And there you have it, that's our answer.
This is our flowchart. First, you have to read the problem. It's very important that you understand. Next, you have to analyze the given graph. Then, identify the amplitude so you can graph it. Identify the period and solve for omega. And finally, find an equation of the form d of t equals a sine omega times t.
Simple harmonic motion is a type of periodic motion where the restoring force is directly proportional to the displacement. With this project, we came to a conclusion that simple harmonic motion is very useful in the life. For example,
we can use it to model the number of hours of daylight, model the alternating current, and even model the blood pressure. The final answer of a problem is the function that describes the mass attached to a spring moving up and down in simple harmonic motion.